Section 5.3 is on the rational numbers, and this is part 1 of a 2-part video. The rational numbers, whenever I hear that vocabulary, rational numbers, I immediately think of fractions. So these are your fractions, which sometimes can reduce down to, an integer number. But there are 2 different ways you can think of the definition. So the first way is you do see the word ratio in rational, and ratio means division in math. So this is a ratio of integers. Think of your last video. We said the integers are the non-decimal numbers. So if I take the ratio of integers, it really just means I'm taking an integer and I'm dividing it by, I'm going to use fraction bar for division, another integer. So whenever I have an integer divided by another integer, voila, I have a rational number. There is one exception to this. Remember, in math, we can never ever divide by 0. We can have 0 on the top of a fraction, but we cannot have 0 on the bottom of a fraction. So I'm going to write not equal to 0 on the bottom of the fraction bar. So pick any integer in the world and divide it by any integer in the world except 0, and then voila, you have yourself a rational number. The other way you can think of this is whenever you have an integer divided by another integer other than 0, it creates one of 2 special types of decimals. It creates a decimal that either repeats the same pattern over and over again, so we call that simply a repeating decimal, or it gives you a decimal that ends, that does not go on forever. We call that a terminating decimal. So these are your repeating or terminating decimals. Just enough room to squeeze that in with my big old handwriting. So let's give you some examples. I'm going to write EX to abbreviate example. I'm going to pick an integer, any integer. Let's say that I pick -1 and I divide it by any integer besides 0. So I'll pick 2. I'm not super creative here. If I take -1, that integer, that non-decimal number, and I divide it by another integer, 2, that is a rational number because I have an integer divided by an integer. It's also a rational number when I look at the decimal it produces, because -1 divided by 2 on the calculator is going to come out to be -0.5. So this is a decimal that ends. It's a decimal that terminates. Let me think of another example. If I take 1, the integer 1, and I divide it by the integer 9, I have an integer divided by an integer, a non-decimal number divided by a non-decimal number, so I do have a rational number. But also, if I do that on the calculator, it's 0.111111, etc., where that 1 repeats, so I would draw a bar above it to show that it is repeating. But the point is yep, it produces a repeating decimal. Repeating in that it repeats the same pattern after the decimal point forever. So repeating or terminating decimals are created by an integer divided by an integer, which are your rational numbers. Technically, you might be thinking of some different examples. Like, let's say that I had an improper fraction example. Let's say that I have 8 divided by 4. That's a rational number because I have a non-decimal number, an integer, divided by another integer. If I divide that out, that gives me 2. And you might be saying, but that's not a decimal. Well, technically, I could write it as a decimal. I could write it as 2.0. So technically this is a terminating decimal, which is why 8 divided by 4 is a rational number. What's interesting about this last example is that 2 is also an integer. I was calling it a non-decimal before as slang because 0.0 is the only thing in the decimal portion. So sometimes, not always though, but sometimes a rational number can be reduced into an integer. So my point is that with all this vocabulary in this chapter, you're going to see a lot of overlap between the types of numbers. Looking at example 1, It says to reduce the following to lowest terms. A, we got 72 divided by 90. Couple of different ways you could do this. If you wanted to do it longhand, you could try to think of the GCD, the greatest common divisor, that would go into both the top and the bottom numbers and divide by it. And that way you can quickly reduce your number. Another option, if you're doing this longhand, is to just keep dividing whatever number goes into 72 and 90. Whatever number goes into those numbers besides 1, just keep chipping away at it. So like for example, I could say, well, 72 and 90 are both even numbers, so I can divide them both by 2. Is a number that goes into both numbers. 72 divided by 2 gives you 36. 90 divided by 2 goes into 45, and you just keep doing this over and over again until there's no number other than 1 that will divide into the top and bottom of your fraction. So we're not done yet because there are numbers that go into 36 and 45 other than 1, 9 for example. So now I can divide by 9 on the top and bottom. 36 divided by 9 gives me 4 on the bottom. 45 divided by 9 gives me 5. 4/5, now only 1 will go into both 4 and 5, so that must mean that this is in lowest terms. So you could just keep doing that, just keep asking yourself, okay, is there a number other than 1 that divides into my top and bottom? If so, keep dividing, chipping away at your fraction until it is reduced. But an even quicker option is you could make the graphing calculator do the work, because remember, you're encouraged to bring your graphing calculator with you on test day anyway. So let me go ahead and bring up my graphing calculator onto the screen, and I'll show you how you can reduce 72 over 90 with just a couple of button clicks. To begin, you're going to type in 72 over 90 like you normally would. So 72, fraction bar just means division, so I'm going to hit the division button, over 90. Then you're going to hit the math button to try to reduce it. Math button is the third button down on the left side of the calculator. It's below the colorful alpha button. I have an 84. You might have a different version, graphing calculator, that's okay. Maybe you have different colored buttons, that's okay too. Third button down on the left should be the math button. And then frac for fraction is already highlighted is the good news, so go ahead and hit enter on that. Frac comes onto the main screen, then hit enter a second time. Ta-da! 4/5, final answer. So a lot of students just memorize math, enter, enter to reduce. Let's try it again. 72 divided by 90, math, enter, enter. Same answer. Even if you have a fraction that you're not sure about if it reduces or not, it doesn't hurt to try it in the calculator. Like if I do 4 divided by 5, it's already simplified. So when I do math, enter, enter, it just comes back same fraction again. But it doesn't hurt to check. Going back to the original question, let's say that you forgot to hit the math button. You did 72 divided by 90. You hit enter, you got the decimal. That's okay. Even after you got the decimal, you can still hit math button, enter twice, and still get the same exact final answer of 4/5. Let's go ahead and take a look at B. B is 60 divided by 108. I'm going to go ahead and do that in the calculator one more time. I'm going to go ahead and type in 60 divided by 108. There it is on the main screen. Math, enter twice, and 5/9 is the final answer. I'm going to write that in, so equals 5/9. The other way, one of the other ways you could do it longhand is you might have noticed that 12 is the greatest common divisor because 12 is the biggest number that divides into both 60 and 108. So if you divide the top and bottom of the fraction by 12, that's just one of the many ways you could also get 5/9, that fraction that's reduced there in lowest terms. For examples 2 and 3, we're going to be converting back and forth between improper fractions and mixed numbers. Before we do that though, we first have to be able to recognize a proper fraction, an improper fraction, and a mixed number. So looking at the definitions at the top of the screen, a proper fraction is where the larger number is in the denominator. So for example, I'll use EX to abbreviate example. If I had 2/3, clearly the bigger of the two numbers is on the bottom of the fraction, so 2/3 is a proper fraction. Improper is going to be the opposite because the prefix im means not. So an improper fraction is when the larger number is in the numerator. So for example, if I flipped it upside down and I had 3/2, it means a totally different number, obviously, than 2/3. The bigger number, 3, now it's on the top of the fraction, so now it's an improper fraction. Improper fractions we can convert to mixed numbers. We could also convert them to decimal numbers as well. But we're going to go back and forth, we said in examples 2 and 3, between improper fractions and mixed numbers. A mixed number is a whole number plus a proper fraction. So for example, if I saw 5 and 4/7, this is a mixed number because I have a whole number such as 5 there in front, and you have 4/7, a proper fraction beside it. It's a proper fraction because the bigger of the two numbers, 4 and 7, is clearly 7, and it's on the bottom of the fraction. What's implied every single time you see a mixed number is the addition symbol. So when I have 5 and 4/7, what this really means is 5 plus 4/7. If I wanted to know what decimal it's equivalent to, I could type it in just like that, 5 plus 4/7 into my calculator. You could have negative proper fractions, improper fractions, and even negative mixed numbers, so we will see some of those. So let's go ahead and take a look at example 2. I'm going to erase a little bit just to create some room. So looking at example 2, it says convert the following improper fractions to mixed numbers. So we got an A, B, and a C. We do currently have improper fractions because the bigger number is on the top of the fractions. We have 49 on top of just little 6 here on the bottom there of A. So A, 49, 6. Let's start with this one. And whenever we're going from improper to mixed number, we're just going to simply divide. Fraction bar means division anyway. We're going to divide out our number, and we're going to format our answer as a remainder number rather than as a decimal number. So 6 is going into 49. I'm going to do division longhand. 6 goes into 49 8 times, because 8 times the 6 would be 48. 9 would be too big because 9 times the 6 would give you 54. So 8 times for 48, then we subtract. 49 minus the 48 gives you 1. So I have 8 with a remainder of 1. Now if you're going, that process does not look familiar, the symbol we use for longhand division is different in the United States than it is in other countries. So feel free to do this long division whatever way you learned it. It's still the same exact process regardless if you use this notation or not. But any way you do it, you should be getting 8 remainder 1. That whole number answer you get will be the whole number that'll go in front of your final answer. So 8 is the whole number. The remainder, put it over the same exact denominator that you started with. So my remainder was 1 over the original denominator was 6. So bring over the 6. There's my final answer. So 49 over 6 is the same as 8 and 1/6 as a mixed number. Let's try example B. And I'm going to move this answer over. Again, my handwriting's so big, I need to create some room here, some space to write for B. So A was 8 and 1/6. Now, B, we have -7/3. Don't worry about the negative symbol until the very end. We're still going to do the 7/3 part just like we did example A, but just don't forget to bring over the negative symbol because it is going to be part of your final answer. So I'm going to go 3 into 7. Number on top goes under that division bar. 3 goes into 7 2 times, of course, for 6. Now we subtract. 7 minus the 6, obviously 1. No digit left to bring down, so this 1 here is our remainder. We get 2 remainder 1. So now it's just a matter of formatting our answer as a mixed number. Again, don't forget that negative symbol. That's part of the overall answer. It's so easy to do. You might even want to write down your negative symbol on the bottom line of your scratch paper before you forget. The whole number is your 2 there, and your remainder 1, throw it over the same exact denominator that you started with. We started with a denominator of 3, and there we go. So -7/3 is equivalent to -2 1/3. Now let's look at example C. I'll do it with the black pen. We got -101 divided by 8. So let's go ahead and do 8 into 101 off to the side here. 8 first goes into the 10 one time, so 1 times 8 for obviously 8 again. 10 minus the 8 for, of course, 2. Not done yet because I have a digit to bring down. We don't have our remainder until there are no digits left to bring down. So now I'm going to do 8 into this 21. It's going to go in 2 times. 2 times the 8 gives me 16. Go ahead and subtract. 21 minus your 16 gives you 5. There aren't any digits from the 101 number to bring down, so that means that this 5 is my remainder. So I get 12, remainder 5. Now let's go ahead and just reformat this answer as a mixed number. Don't forget to bring down the negative symbol. My whole number was 12. Take your remainder of 5 and throw it over the same denominator as the original question had. The original question, the denominator was 8. So -12 and 5/8 is the final answer. Now, if you're wondering what number, decimal-wise, this is the same as, please be aware, because we said earlier in this video that mixed numbers, addition is implied, but just be very careful with this negative sign. So if you wanted to type this into your calculator because you wanted to know what decimal this is equal to, you would have to type in negative symbol, parenthesis, then the 12 plus the 5/8. Close the parentheses. So you'd absolutely need those parentheses around the 12 plus the 5/8. Now we're going to go in the reverse direction. Example 3 says to convert the following mixed numbers to improper fractions. We're going to follow the same pattern for each of these. So once you find out what the pattern is in A, you're just going to duplicate it for all the other examples. So you're always going to take the number in front and we're going to multiply it by the bottom number to begin. So 2 times the 8. Then after we do that, we're going to add the remaining number that was in the numerator of the proper fraction. And we'll keep the same exact denominator on the bottom of the fraction there. So originally the denominator was 8, so we keep that 8. So again, really all the action that's going on is in the numerator clearly. So I have an acronym here, MBAT. I know that's not even a word, right? But M stands for multiply, B stands for bottom, A stands for add, T stands for top. So multiply by the bottom, add the top. So I took the number in front and I multiplied it by the bottom number. That's why I have the MB there. So I did 2 times the 8. AT stands for add the top, so I did add the top number. I added the 5. So 2 times the 8, let's compute out now, it gives me 16. Add to the 5, just keep bringing the same denominator over. Now do 16 plus the 5 for 21, and bring over the over 8. So 2 and 5/8 is the same as 21/8 as an improper fraction. Final answer. Taking a look at B, oh, be so careful with B because it's a negative number. It's so easy to make a mistake, a sign error here, and get a completely wrong answer. B is -4 7/9. So I don't want to forget that negative sign, which is easy enough to do. So I'm going to bring down the negative symbol, but take a look at what I'm doing here. I'm immediately putting a parenthesis after the negative symbol. Now I'm going to use my acronym MBAT to figure out what to do on the top of the fraction, the numerator here. So MB stood for multiply by the bottom number, so 4 times the 9 on the bottom. AT, add the top number is 7. Close those parentheses. Divided by, I don't have a fancy acronym for the bottom number because you don't need one. You just keep the same denominator every time. In this case, it's 9. Now let's just do the computations in the parentheses. 4 times the 9 gives me obviously 36. Add the 7, 36 plus the 7. That's going to give me 43. Bring over the over 9, and don't forget the negative sign. There it is. So -43/9 is my final answer. But you can see what I mean by, if you forgot those parentheses around the inside, you would get a totally different answer. You want to make sure that you're always adding that 7 to that product of 36 before you bring over the minus symbol. And finally, C, I'll do in black pen. So I do see another negative symbol, -3 4/5. I'm going to bring down the negative symbol, put the parentheses after it. Now time to use the acronym MBAT. So I'm going to figure out the numerator with that acronym. So MB, multiply the number in front by the bottom. So that's 3 times the 5. Then add the top. AT, add the top. So that's a 4 this time. So plus 4. Keep the same denominator, which in this case was 5. Time to do the computations. Bring over the negative symbol. 3 times the 5 gives me 15. Take the 15, add it to 4, gives me 19. Bring on over the over 5, and bam, there's our final answer. So -3 4/5 is the same as -19/5. Final answer.